We're starting, because it's a new concept, flying these things vertically. We have done about 5 ramjet flights, and these are all starting from the separation point. It's a new system, it's a new approach. We want to start, right at the bottom and start walking it up. And we've done the first 2 ramjet flights were just to demonstrate the separation from the rocket booster, the first stage, deployment of the shroud, and then ignition of the second stage motor to start it in the ejector ramjet, or really in the ducted rocket mode, to see if the ramjet's flying right. We've done that. We designed the first fuel one. We had 3 flight tests, but we had some electronics issues initially, and then ignition of the second stage motor in one of them. And those are all, that's what you're typically going to go through in any new system. The thing about it is these flight vehicles, we make them for about $50,000. And most of the parts are reusable. We reuse the booster and everything else. So we want to flight test. If we could flight test every month, we do 2 flight tests a day. We could even boost that up to 4 flight tests a day. Change little things here and there, and then just keep working the problem. And pretty soon you're stepping up in speed and you're stepping up in altitude. And that's really the way that you're going to prove it out. And while you're doing all that, you're also verifying your numerical design tools that you've developed, as well as basically verifying that your ground test facilities are operating correctly and the information you're getting out of that is correct. So that's the direction that we're going in. But right now we're just starting that ramjet or ejector ramjet, where we're kicking in the liquid fuel into the ramjet. We're just starting that phase of it now.
So what sort of other objectives would you need to accomplish before it was in a full flight capability?
Well, one of the big things right now, well, I shouldn't say right now, the largest thing is running the air breathers over a wide speed range. No one's done that. You can't simulate this in a wind tunnel, because wind tunnels are typically, you're running them at 1 speed, 1 condition. Where we're running near vertical, we're going to be changing speed, constantly going up. The altitude's changing, so the pressure's changing. Everything's basically transient in the flight. And so that hasn't ever been done before. But if we can do this low cost, let's try it out, because we'll get the hang of it. We just need to go out and do it. We need to do it a number of times, which is why we try and drive the cost down as low as possible.
According to your data, how high, what kind of altitude would the ramjet go to before the air breather would cease to work?
Right now we're looking, our models are telling us at about 120 to 150,000 feet, but running at fairly high Mach numbers compared to what you'd see a rocket at those altitudes. So we'd be running somewhere between Mach 15, Mach 16 an air breather before it shuts off, and then kick in the final stage rocket at that point to continue up. So, hitting Mach 15, Mach 16, you got a good portion of the delta V covered. So you have to get to those points in order for it to really be worth it. And the thing that we're doing different than the traditional air breathing, the scramjet folks that are out there, is we're not looking at the Wave Rider type vehicle. We want to make this vehicle as light as possible, as simple as possible, axisymmetric design. Go is, almost vertical. We're going to start leaning over, of course, inserting into orbit, you will be. So we want to reduce the time that we're actually operating, and that's really the key, where the Wave Rider type designs and even the weapon systems that they're developing now, they want to go for long periods of time. We want to go as short as possible, because the heating loads when you're in the atmosphere kill most of the design. It's prime. That's like the major point to getting these systems to run, because we've run ramjets, scramjets, short amount of time, 5 seconds. X-43 ran at Mach 10. But if you're going to run them a longer period of time, you're going to have the thermal load that starts to. It's at some point the vehicle is going to say, "Hey, I can't take any more heat. I'm done. You're off." We don't want to get into that. We want to run this thing maybe 30 seconds, done, and be out there, be up to where we need to be in terms of speed. So make it very lightweight. While we're testing this thing out, getting it up to speed, we make it very lightweight. We can get high acceleration rates. We also get high deceleration rates. We get very good thrust and drag measurements from the vehicle being lightweight because of those the high numbers on the accelerometers that we get. So we get some really good data out of these flight vehicles, and so that's the direction that we're pushing.
So if all of these concepts are proved out, could this type of vehicle eventually be expanded and become larger to have heavier payloads delivered to orbit?
I think that would be the natural transition for it. And the lighter vehicles makes a lot of sense because it would be lower cost to develop. In flight testing them, we're flight testing something right now that's 6 inches in diameter. It's where the military started out when they were running ramjets, the Bumblebee program that the Navy did way back when in the 1950s. That's where they started out. Just to try them out, we got to get out there and we have to flight test these things. We have design tools, we've got ground test facilities. We've done a lot of work in those, but we need to get the flight test done. We need to do low cost because right now that's what they don't have. So let's start there. That's our thought, is to start there. And we can work with these smaller scale vehicles and ramp them up because we're going to learn from those flight tests. And I think it's a natural progression of the technology. And pretty soon, you're flying the bigger systems, and maybe the commercial aircraft industry is using them as well, because if you can go halfway around the world in an hour and a half, then you got the same crew going back and forth very quickly, same equipment. I think it's a natural progression. Run it to bigger vehicles, and then you'll see the markets, I think, would just open up. And rockets are always going to be there. We're not looking to replace any rockets. We're looking to open up markets. And I think the combination of both of them makes a lot of sense.